Today we are going to draw the Mohr circle and then try to find out the principal stresses based on the Mohr circle. So first of all, we had a stress element. The first thing you need to do is try to draw the original stress status. So based on the given information, we had a sigma x is positive, which means we are going to have tension. And then the tau xy is negative, which means the shear stress on the x face must going down. So after this, we can do head by head, tail by tail to finish the shear stress. And then the sigma y is negative, which means we are going to have compression. So this is the original stress status. We are going to draw the Mohr circle based on these original stress status. So first of all, we need to find out where is the center of the Mohr circle. That's actually going to be sigma average. So which means we are going to use the value to calculate. So we find the center of the Mohr circle, which means we were ready to start our drawing. First of all, we need to set up the coordinate system. And remember, going down will be positive. So we mark the center of the Mohr circle. It's going to be somewhere here. And then the next thing we are going to do is actually try to find out a point on the Mohr circle. And this point is the stress status on the x face. So which means it will be. So now what we are going to do is try to go to the coordinate system. So x will be here. And remember, going down is positive, which means we have to mark our point, x point, above the horizontal axis. And then you can use your compass to draw the circle now. So now on the Mohr circle, we will know we need to find out the principal stress, which means we need to find the sigma 1, which is the maximal, and sigma 2, which is the minimal normal stress. We also need to find the maximal shear stress later. So now take a look at this picture here. We know in order to find out the maximal normal stress, we need to find the distance from origin all the way to this point. And this distance is actually going to be break into two parts. You can see that's actually the center of the Mohr circle, and this distance here is actually the radius of the Mohr circle. So which means we have to find out the radius of the Mohr circle first. How we are going to find the radius of the Mohr circle? We need to construct a triangle always based on the OX line. So let's take a look at this blue triangle we just built based on the OX line. So we can see this is the height of triangle, which is the shear stress. And then the hypotenuse is the radius of the Mohr circle we needed. So now let's take a look. What is the base of this triangle? So if we can find the base of the triangle, we will be able to obtain the radius of the Mohr circle, right? So now we have to go to the geometry one more time. See, when we try to locate the x location, this is actually the horizontal distance we need to go, right? So we can see if we use the sigma x minus the center of the Mohr circle, we will get the base of this triangle. And finally, we find out the radius of the Mohr circle will be 94.95. Okay, so which means we will be able to obtain sigma 1 will be center of the Mohr circle plus the radius. So now what we are going to do is try to draw a new stress element that's going to represent the stress status at the maximal normal stress point. What we need to do is one more thing, find out this angle. This is called 2 theta p1. So how we are going to, why we need to find this angle is because that will tell us how we are going to rotate our original axis to the new axis. Then we are going to have the new stress element represent on the Mohr circle. So how we are going to find the 2 theta P1? We still go back to the blue triangle. So now let's start to draw the rotated stress element. So this is our original coordinate system. And now we are going to rotate our axis, which is the OX line, clockwise to the maximal normal stress. So which means in the original system, we are going to rotate in the same direction but half of the angle. So that's a new coordinate system. And try your best to draw a stress block. So now what we are going to do is try to draw the stress status on the new element. So what is the point here on the Mohr circle? We just find it will be. So which means on the positive x prime face, we are going to have maximal normal stress. And then the shear stress will be 0, so we don't need to draw the shear stress on this face. So now if we keep rotate our OX line clockwise, we are going to go to the sigma 2, which is the minimal principal stress, right? So which means on the original coordinate system, we're actually going to go to the y prime. And since we had 0 here, which means we don't have shear stress. So the new stress element was done. So now what we are going to do is actually draw what is the maximal shear stress. So for this maximal shear stress, we can see the point, I just mark here, is actually going to have the maximal shear stress, which is the radius. However, the normal stress at this point here is not going to be 0. It's actually going to be the center of the Mohr circle. So now how we are going to get the angle? We still go back to the OX line. So we can see we need to rotate this angle here to reach to the maximal shear stress point. So we call this angle is 2 theta S1. So based on the geometry, we can see it's going to be 90 degree plus 2 theta P1. So now we were ready to draw the stress element. Again, try to draw the original coordinate system. And we are going to rotate clockwise this degree to get to the new coordinate system. And then try your best to draw the stress element. So now let's take a look. On this stress element here, we do have a normal stress. And the shear stress here is positive, which means on the positive face, it had to go the positive direction. So we can try to draw the stresses on the y prime face. So this is going to be the new stress element on the maximum shear stress status. So be very careful here. If we were trying to only draw the principal stresses, you can see we don't have any shear stress on the principal stress plane. However, on the maximum shear stress plane, it all depends on if your center of your Mohr circle will be 0 or not. If your center of your Mohr circle is at 0, then which means you don't have normal stress. However, if the center of the Mohr circle is not at the origin, you have to show the normal stress on the maximal shear stress plane.